In this example problem, we're going to find the equation of a polynomial when we're given some roots. In this case, we know that one root is at x equals 3 plus I, and the other one is at x equals 5 halves, but it has a multiplicity of 2. Let's start with the 5 halves with a multiplicity of 2. We know right off the bat from this that 2x minus 5 squared is going to be a factor of the polynomial. We know this because we're given a multiplicity of 2. Whoops, I didn't mean to erase there. We're given a multiplicity of 2, and we know it's 5 halves. And so how do we know that that becomes 2x minus 5? Because if 2x minus 5 equals 0, it means 2x equals 5, and x equals 5 halves. So we know that 2x minus 5 squared is going to be a component of the polynomial. Now what do we do with x equals 3 plus I? Well, whenever you're given an imaginary root, you know its conjugate is also a root. So there's two ways you can go about it. I'm going to show you kind of the long way first because it's conceptually what you probably already know. That we can say x minus 3 plus I times x minus 3 minus I, the conjugate. And then we just use whatever distribution method you like. I'll just go ahead and use FOIL. First becomes x squared, outer minus x times 3 minus I, inner minus x times 3 plus I, and then last plus 3 plus I times 3 minus I. Now we just distribute and combine all the like terms. X squared minus 3x plus ix minus 3x minus ix plus, let's use FOIL again, 9 minus 3i plus 3i minus I squared. Look what happens. We get a lot of things canceling out. We've got, oh, nope, that doesn't cancel. The ix and the negative ix cancels, and the negative 3i and the positive 3i cancel. And what are we left with? We're left with x squared minus 6x plus 9, and then of course minus I squared means negative 1. So this is x squared minus 6x plus 10. So our final polynomial is it g of x? Did I call it g of x? I think we'll just call it g of x here. G of x equals x squared minus 6x plus 10 times 2x minus 5 squared. Now there's a slightly easier way to come up with that x squared minus 6x plus 10. I'll show you that down here. This is of course a perfectly acceptable answer. If we know that x equals 3 plus I, all you need to do is subtract 3 from both sides to get x minus 3 equals I. Square both sides. So this is x squared minus 6x plus 9, and that of course equals negative 1. Add the negative 1 to both sides, and you get x squared minus 6x plus 10 equals 0. And now here is our imaginary quadratic. Okay, and so then you can plug that right in there. Either way is perfectly acceptable. This way is a little quicker. It also takes care of the plus or minus I conjugate by squaring it right there. Comment if you have any questions.